Well, good morning, ladies and gentlemen. I hope you had a wonderful weekend and enjoyed only having 2 lessons last week instead of the usual 3. My plan is, and you should have gotten an email to this effect, that we are going to be doing an every other day. So we're going to be doing Monday, Wednesday, Friday this week, and then Tuesday, Thursday next week. And that way you'll have, just like we were in school, 5 classes over 2 weeks. And we'll do a lesson each time, and there'll be an assignment. What we would like to see happen, okay, is that the assignment that's done Monday is done before Wednesday at 11 a.m., okay? That way you can get full credit for it and that sort of stuff, because as you've noticed, or if you haven't, you're silly. And if you've been watching the videos, I generally go over the homework when I start my lesson, okay? So if you don't have it in before that Wednesday at 11, it'll be considered late, and there'll be some sort of penalty for that. And hey, if you're going to copy the homework off of the new lesson, do all the work. Oh my goodness. I see people writing in answers when it's like, yeah, you need to show me some work. All right. And I am going to be grading this on effort, timeliness, and accuracy. So now it's going to be important that you get it right. All right. And I will point out to you what your errors are, and you can maybe do some corrections on it. Haven't worked all the details out on that as yet, but we'll get there. And yeah, hopefully we'll be done with this thing by the 1st of May, and we'll get back to normal. But until then, this is the plan for what's going on. The Delta assignments, you won't have to have done by Wednesday, okay, when I sign it on Monday, because I'm not going to be going over those. The Delta assignments are going to be done for accuracy, though. It shows me how many you get wrong, so if you're just guessing until your brains fall off, that will be noted. And I've upgraded my Delta to Delta Plus, so there should be a video lesson there. So if you are struggling with it, have another source for a video available there to take a look at, and hopefully that'll all help for you. Now, today's lesson, I'm going to have to go back and look again because I'm changing it a little bit on the fly, and I'm not sure whether there'll be a Delta assignment for this one. This one is going to be called the Vertex form of a parabola, and I think they have some questions and problems on that, but I didn't quite look at it. I just changed my mind about, 5 minutes ago. I've been debating it back and forth for 3 or 4 days, and that's where we're at. So, here we go. Now, last time we were talking about real-world situations and completing the square. All right, and when I get to the completing the square, we'll talk about that. And on page 36, you had a choice of which one to do, and this is the way this one turned out. First of all, let's kind of read through this. The height of an object traveling through the air can be modeled by a quadratic function that opens downward. Okay, that's because of the negative there. And the object is fired upward, and its height in feet above the ground is given by that equation. It's a very common type problem, okay? And they have it so that the numbers come out real nice, so it doesn't go out for like 200 years and come back down. Excuse me. Okay, so here we go. And once again, when you go to key this into your calculator, you would not want to put a t squared. You'd want to put an x squared there. Okay, so you type this in your calculator, and it's going to give you a picture. And actually, I don't think anything really even shows up on the picture. I don't think I made this one up. But we will take a look at it in a moment. Well, let's go through what I have here on the screen. And once again, using without a calculator, I figured out that the axis of symmetry is at 2. Because I put in my 64 with a negative from the negative 2b. And then I have over 2a, which is 2 times negative 16. That gives me 2. And that's how I got this right here. Okay, it's my axis. Okay, and then I plug that in by hand. And I did 2 squared times negative 16. And that would give me a negative 64. And then I'd get 64 times 2 is going to be 128. And then a plus 80, and if you do that math, it winds up at 144. So I know that I have that max right here at 2 and 144, and I can also go out here, since this is 2 units from here to here, I also know it's going to go through that spot right there, 2 units away from the axis of symmetry. That's what symmetry does. So I know at 4, it's at 80, and when I did it, I didn't use my calculator. I figured out where my where it's going to hit the ground by doing some factoring. All right, and here's what you see. It says, what time does it hit the ground? and I see that it is, I divided everything by 16, and that gave me this equation here. Then I factored that, and I set both of the factors equal to 0. Now, that means that back over here at -1 would be my other 0. But once again, this is a real world situation. Therefore, I don't have to worry about that -1. It's not going. You can't say, well, when I shot it -1 seconds ago, it hit the ground. That's not what happens. It happens over here at +5 seconds. Then the last question, they say, well, over what interval is the height increasing? And once again, increasing means it has a positive slope, so it has to be going up from left to right. So that's from here to here. And you can put a line underneath this one because it does include 0 because it starts out increasing, but not here, because when it gets to the vertex here at 2 and 144, it's changing direction. So technically the slope right there at 2 is 0. All right, so it should look like that. And if you did it in interval notation, it would be a square bracket with a 0, 2, rounded bracket. Okay, so that's the first one. All right, once again, real world situation. This is nice because they gave you the scales. You didn't have to try and figure things out. All of a sudden you see this 160, you know you're gonna have to change your window on that. In fact, if I was doing this in the calculator, first thing I would do is change this to the 160 after I put in my equation. And you could leave your screen at 0 through 10 because that really would make a big difference. And then use your table of values. So that was the first one on the top. Once again, you had a choice on page 36, the top problem or the bottom problem. Sorry about that loud clunk. My son may take it out, but may not. And then down the bottom, we have this equation. And this one is actually more realistic, okay? This is the type of things that's shown up from the Regents exam. I know we're not doing a Regents this year, but someday you're going to probably have to take one. And they give you more complicated equations than we do in class. Once again, we want you to be able to do it when you're in class. They get a little bit more technical, a little bit more difficult. All right, so here's our equation. 1 over 500 n squared minus n plus 200, where n is the number of computers produced in a day and C of n is the cost. So here's what they're saying, is that the cost can be modeled by the number of computers. Like if they don't make any computers today, they still had to pay $200. That means that was their rent for the building for the day or something to that effect, or the cost of the parts for a computer. I'm not sure, but that's automatic. And it opens upward since this 1 over 500, even though it's really, really small, is positive, okay? And what else? Well, first they say, what's C of 50? So you put in a 50, 650. That means if they make 50 computers on a day, it would cost them $650 each. Okay, and this really is a real-world situation. You know, as you make more computers, it doesn't necessarily mean that the cost goes up that dramatically. In fact, the cost can come down because the more computers you make, the less you have to pay a person to make that computer. Okay, because if they make 1 computer a day, you paid them for the whole day. If they make 50 computers a day, you can take the cost of their work over those 50 computers. That's what's going on here. All right. So, and it says, does the cost have a minimum or a maximum value? And it's going to be a minimum since this is over greater than 0. And explain how you use it and find your calculator. Well, if you do your negative b over 2a, it would tell you that your minimum is going to be at 250. And I think if you plug in 250, it winds up being 75 at your output. So the lowest cost they could have for a computer is $75. All right, once again, it'd be a big loop. And it says, based on book, can this function have any zeros? No, because if we did this, it would be something like this, and it would be going whoosh. And once again, it would start at 200 here, and then at 250, and that would be at 75. So it never crosses that x-axis, and that's what they were asking for. That's what the roots would be, the zeros. All right, so that was the first page. And then you had a choice on pages 39 and 40. All right, so let's take a quick look at 39 and 40. And I did the first one out for you. All right, once again, they ask you to do this by doing the completing of the square. So that's what you should have been done. I had some people that went ahead and factored some of these things. And yes, they're factorable just so you can have practice and it works, but that's not what the whole process was supposed to be here. All right. So this is what you're supposed to do. Once again, you move the C. That's why it came over this side. You take half of B, so negative 20 over 2 gives you negative 10. And remember, when you square a negative, it's positive. So negative 10 squared equals 100. And that's how I got the plus 100 there. Whatever I do to one side of the equation, I do to the other side of the equation. And this is what you get. You get 68 equals x minus 10 quantity squared. It's a minus because that's a minus 20. And it's a 10 because 10 squared is 100 and 10 plus 10 is 20. And then you take the square root of both sides, and the square root of 68 is an irrational number. Okay, and you don't want to put that in your calculator yet. You want to write it out. So I move the 10 over to the other side. And the other big deal is this plus and minus. You have to have the plus and minus. Without the plus and minus, it's going to be wrong. And then you put 10 plus the square root of 68. That's how I got the 1825. And the 10 minus the square root of 68, 1.75. If it doesn't tell you to round to the nearest hundredth, I'm telling you right now, anything in these packets, round to the nearest hundredth. Okay? This right here is an exact answer. And this is an estimate. Okay? So if they don't tell you to round to anything, I would leave it like that personally. Now, there is something called rationalizing or working with a square root, so it's in simplest form. We will cover that, I think, after next week. I'm not exactly sure how in depth we'll go, but you'll get the idea. All right, and then this one factored, but you can just do the process. And then this one's a little bit weird with some decimals, and I didn't put that in my calculator. What a slacker. Oh my gosh. Well, let me show you how to put that in your calculator. I'm not going to do it for both of them. And there's my 75 for my minimum. So I do 2.5 plus control square root 3.25. That gives me 4.30 because that 2 is less than 5, so I have to round that down. And then I can arrow up and arrow back and just change that to a minus. And you're going to be doing that a lot when we do the quadratic formula, so remember that. And that leaves me with a 0.70. Don't forget your comma between them. All right, and then we can do the same thing for the next one. We have 7 plus control square root 33. And I got a 12.74. Arrow up, enter. Whoops. Minus, make sure you do a minus and not a negative, and that gives me a 1.26. Don't forget your decimal point. Make sure your decimal points are really visible. You don't need to make them like super huge, but make sure you can be seen. Okay, that's important. And so there's the first page. And flipping over to the second page, I guess I got to slide up a little bit. And page 40. So we had a bunch that worked, and many of you did that by doing the just factoring. Like I say, if they ask you to do it a certain way, do it that way so you get that practice in. Like this one, rewrite it x squared minus 12x, leave a space, equals 28. So I'm going to take that, and I'm going to do negative 12 divided by 2. It's going to be negative 6. Negative 6 squared is positive 36. So I add 36 here, plus 36 here, and this is now a perfect square, so I get x minus 6 squared equals 54. All right, and I square root, I get x minus 6 equals plus or minus square root of 54, and I'm not going to do the decimals here, but you get the idea. I add 6 to both sides. And my exact answer is 6 plus minus square root 54. Okay, so that's that. And once again, the last one's got a single root. If we graph this one, it would look like this. And it would be whoosh. And we'll just touch one spot at 6. Okay, single root. Once again, that's called tangent to the axis. And we're going to hear that word again in a couple of classes, but that's going to be something you're going to work with next year. All right, so let's take a look at what we're doing here. So we're going to be going on to page 41, I think it is. Anyway, it says, I can find the critical points of a parabola in other formats. Okay, well, we've always been using y equals ax squared plus bx plus c. Okay? And that's the standard form of a quadratic equation. Well, this is another form of the quadratic equation. And if you have your calculator, it would be nice to be able to punch it in. In fact, I'm going to punch in the second one. I already have the first one done for you. Now, if you have one of these calculators, go ahead and put it in your calculator. Go ahead and put that one in, and we're going to talk about that a little bit. But we're just going to look at it real quick and see how this works. I'm going to go to a graph, and you got to type it in just the way it is. And I have the parenthesis, and I do x plus 1, close it, square it, minus 7. And I hit enter, and you see that parabola, and it looks, that looks kind of familiar. Let's see what our vertex is. That's what they ask us for. And I do my Control T. And we're looking at that low spot, and I got arrow up, and I see that it goes. So it's starting here at 2, and then -3, and -6, and -7, and -6. So my low spot there is at -1, -7. Okay? And if I look at what I do with it, this one right here, I keyed this into my calculator and printed the picture, so it's a little bit bigger for me. And I printed that first one in, and you can see that I have 5, 2 as my vertex. I did that by doing the menu 6, I think it's 3 minimum, and I got 5, 2, so my vertex here is 5, 2. And I think what you'll notice here is that these numbers are right from my equation. Okay, just like this one. But there is one difference. The x term is the opposite sign, the y term is the same sign. Okay, so you can see that if we were dealing with our regular y equals x squared, if we started with that, like here, oh, that was awful. Okay, we moved it 5 units to the right and 2 units up, and that's what's called a translation. Once again, if you remember that from last year in 8th grade, and we're going to learn more about that in the next unit, but that's the basic for what we're doing. This is called our parent function, that y equals x squared. That's not how you spell parent function, and then we move it around by adding and subtracting to the x squared and the end. All right, but the signs change is going to be important. So with what we just learned here, think about it for a second. What would our vertex be on this one? Okay, we know it's going to have a 9 and a 2, but what has to change? We have to do -9, 2. All right, so what you see is when you notice that you switch the sign on the x and keep the sign on the y. So it's kind of like -x, y becomes x plus and x plus. All right, and we're not going to graph A. You can if you want. Well, I can do it real quick. Watch this. I go over 5 and up 2, and there's my vertex at 5, 2. And this is something that you probably should remember. We go out 1, that means we go up 1 because 1 squared is 1. When we go out 2, we go up 4, and once again, we're from the vertex, not from these 2 points I just drew. Out 2, I go up 4, out 2 and up 4, and then the next point won't fit on there because it's out 3 and up 9, because 3 squared is 9. So I just do this. Once again, 5 points is enough to do your parabola, and give yourself a smiley face, and we're going to move on. And if you look at that next page in the packet, I think it's the next page anyway. Oh, no, we're going over to page 43. All right. And this is once again generalizing what I just told you, so don't freak out when you look at this page and go, what's going on here? All right. Basically, they're just showing you that when you have a minus h here, it's a positive h on my vertex, and then the k keeps the sign. Same thing here. When I have a minus h here, my axis of symmetry is just x equals h. Okay? If I had an x plus h squared, then my axis of symmetry would be over here at x equals -h. Okay, just the opposite signs. But this is just a general format of this. Okay, that's why it's called generally expressed. Okay, I had some people that kind of got stuck on this when I was doing it on the beginning of this unit. But they couldn't get past this because they needed to look at what's going on when there's numbers. And I understand this isn't the easiest thing to work with. Now, that a, most of the time, a is going to be equal to 1. Okay? But sometimes it's not. All right? So if the absolute value of a is less than 1, the graph widens. Okay? So if we have a fraction there, so if I had a 1/2 and then the x minus 2 squared or whatever, this would become wider. And if I had it greater than 1, so I had like a 3 and then x minus 2 squared, it would be really skinny. And I think we knew that already. Most of the time, a is equal to 1. If a is less than 1, it's going to be a frowny. Okay, so that still thing comes in. So if I have a is less than 1, no absolute value, that becomes a frown. Okay, when it's in this format, it doesn't change what's going on here with the vertex. Okay, that just changes the shape. Okay, it either makes it fatter, skinnier, or flips it. All right, so that's the basics for all this. So let's take a look on the next page, on page 44. And once again, thinking about what we just learned, where we want to write out the vertex. Okay, and that vertex, once again, they could also call that a turning point. Okay, now if they ask you this question and you're sitting there going, which sign do I change? What am I doing? What's going on here? Well, you can pop it in your calculator and get the vertex off your calculator. Now, there's no rule. It's not like they're going to say, we're taking your calculator away for this one. You can't peek. All right, so if you're struggling with this, it's okay. It's not like they're going to cut you off on that. You're going to be able to use whatever you have available. But if you're doing this, you remember that it was y equals a. Once again, that's to make it fat or skinny or flip it. X minus h plus k. Don't forget your squared, where your vertex is at h comma k. Which means we get a sign flip here on the h. So this -3 is a 3. No sign flip on the 2. So 2. So our vertex is at 3 comma 2. If we want to graph this, it would be like over here somewhere. This one, we're looking for the sign. Look what they do here. They do the switch the x's and the y's, flip all the signs. So there's a really easy way to like work your way back and forth on this. All right, or confuse you. And we don't want to get confused. Sign flip on the 4, no sign flip on the 2. So it definitely has to have a +2. The only one I see with a +2 is right there, and that's got the sign flip on the 4. Yay us. So that's choice 3. All right. Now this time they did something with that a. A is changed. It usually is 1, now it's 2. And then I got the +6 and the -7. Is this 2 going to impact that? What do you think? Well, yes or no? Come on. All right. Well, actually, it doesn't impact it at all. This is still our vertex. That 2 is just going to change the shape of our parabola once we start to graph it. So it's going to be -6, comma, -7. Okay. So now I'd like to work through with you how to change it from standard form to vertex form. And unfortunately, some of what I do here is going to be a little bit different than what it says to do on the side. We're not going to move the C. We're going to move the C over. Okay? Because to change it from this to the other format, you're going to complete the square. So we're going to do some completing of the square, but we're going to do it on one side. So watch what I do here. I'm not going to move it to the other side, and I can leave that y there. All right, I'm going to just spread it out a little bit. So do y equals, I'm going to put a parenthesis here, x squared plus 4x, leave a space there, and put my -21 on the end. Okay, so I didn't change it at all. I just put the y back in. I left myself some space because I'm going to complete the square inside this parenthesis here. So if I do that, I know that b is equal to 4. And I got to change this next year because I really don't want it to be a 4 because that confuses people. I have 4 divided by 2 equals 2. And then 2 squared equals 4. Remember, that's what we did when we did the completing of the square. We took half of the b, squared it, and added it to both sides. Well, I'm not going to do both sides now. I'm going to do it here, and I'm going to show you what to do with the other part. So I have to take that 4, I got to put it in right there. But if I don't do anything to the rest of the equation, I've changed what the equation looks like. So I need to do something so I could balance out the plus 4 right there. Well, I don't want to add 4 to this side. I could. It just caused me an extra step. So what I want to do is put a 4 over here. But since this is a plus 4, I'm going to do a minus 4 there. So the net change to my equation is nothing. I added 4, I subtracted 4. They balance each other out. But I have it in a format now, so I have a completed square here. So this is a perfect square. And this is going to wind up being my y-coordinate of the vertex. So here we go. I get y equals, perfect square is going to be x plus 2 quantity squared. And then negative 21 minus 4 gives me minus 25. I think I have that on one of my sheets. As a matter of fact, I do. So that means I'm looking at this, and if I put that in my calculator, I would have a vertex of negative 2, comma, negative 25. All right, just eliminate that part right there. I used to do it and confused everybody, including me sometimes. I think that's a little bit more straightforward. But if you put this original equation in your calculator and said, hey, where's the vertex? Well, look at this. There's my x squared plus 4x minus 21. I have no idea what that's doing there, but okay. And there's negative 2 and negative 25 for my vertex. Okay. The negative 29.33 is just my picture. Okay, that's what they changed the window to. All right. So here's a hint for you. Like, say you really struggle with this process. Okay. You can get the correct answer by putting this in your calculator and then finding that vertex. You're saying, well, I don't have one of those fancy calculators, Mr. Douglas. Well, you could do is get the axis of symmetry and get it from there. Like that actually would be enough work. If you showed me that x equals negative b over 2a, and in this case that would be negative 4 over 2 times 1, that would give me negative 2. So x equals negative 2, and then you did f of negative 2 equals negative 2 squared plus 4 times negative 2 minus 21. And if you did that out, that would be negative 25, okay? Because this is positive 4 minus 8 minus 21. It's minus 25, not 5. So you've just figured out what your vertex is, and then you said, well, then it was going to be y equals x. Remember, sign change on this. Minus a negative gives me a plus 2 squared minus 25. This technically is also sufficient work. So if you show me this, which I'd really prefer that because that shows the completing of the square, which is something they ask you to do, and get to here, or do it this way. Once again, there's shortcuts and cheats. So I'm going to show you, I think, one more time, and I'm going to give you some work on this. Let's see what we got going on here. All right, so 45. I'm going to do that one real quick. All right, so what do we got going on here? On page 45, they give you this equation here, and they have it graphed. So you could pick out the vertex there, I hope. It says, consider only the binomial x squared minus 4x. What would you need to do to create a perfect square? All right, so that would be negative 4 divided by 2 would be negative 2. Negative 2 squared would be positive 4. Okay, don't forget those parentheses. So you add 4. So I would have x squared. Oh, gotcha. And then I would have minus 4x, and then I'd have plus 4. Okay, and then they say, what should we subtract to offset the adding of 4? So we're going to subtract 4 over here. All right. Yeah, I don't like that, but that's okay. We're going to keep going here. We're changing this one into the vertex form, and then they're going to do it with this one, which is like double work, but okay. So we get y equals x minus 2 squared minus 4, which means if we just had this, that our vertex would be at 2, -4. All right. But if you go back with a -1, all right, then you'd have to play that in there. So you'd have y equals x squared minus, no, x minus 2 squared minus 4 minus 1. So you would have y equals x minus 2 squared minus 5. And that would be a vertex of 2, -5. And hey, look at that. 2, -5. All right. And I'm going to do a couple more of these, and your homework is going to be page 47. 47, and they'll probably be a delta. I think I remember seeing delta on this, but not 100% sure. I'm going to do a couple of these. And all right, I will do A and C. All right, so I'm going to have y equals x squared minus 12x. Leave a space, plus 40. Oh, this one's going to work out nice. I take -12 divided by 2. It gives me -6. -6 squared equals 36, not -36. So I do plus 36. If I add 36 here, I subtract 36 there. So that gives me y equals, this is my perfect square. So I get x minus 6 squared. And this one with the signs gives me a plus 4. So hopefully my vertex is at 6, 4. All right, so how would I check that? Let's just pop that into the calculator and get ourselves a new graph. Oh, for heaven's sake. And no. And type in your original equation. That's not what I wanted. I wanted a graph, you goofball. All right. I was talking to me, not you. Type in your original equation. You know that the vertex of this is going to be 6, 4 because we learned how to use the formula. We want to make sure that this one was at 6, 4. So I'm going to do x squared minus 12x plus 40. Hit enter. And you can see it right there. We could double check it with a Control T. And boom, boom, boom. There you go. 5, 5, 6, 4, 7, 5. That's my low point. Yeah, yes. And I think I'll do B since I'll run out of room if I try and do C. So I spread that out. I've already done that too many times. We'll do this one. All right, so I get y equals a pen that's not going to write, x squared minus 24x. Ooh, the numbers are getting big. And then I put the 146 on the outside. And I do -24 divided by 2. That equals -12. -12 squared equals 144. So I do plus 144 minus 144. And that gives me y equals x minus 12. Well, there's that 12 right there, squared, and then plus 2. Simple as that. Once again, you form the perfect square here. You know what numbers go in the perfect square because you found it right there. Half of b is what's going to go down at that bottom part. And then add it here, subtract it there. It's always going to be an add inside the parentheses. Okay, because when you square a number, it's always positive. And then you subtract it on the outside of your parentheses. All right, so your homework, once again, is going to be page 47. Okay, and I want to see some completing the squares there. And yeah, I think you're going to be okay with that. All right, and then I will see you on Wednesday, and we're going to be doing the quadratic formula. And I'll sing to you. You're going to be excited about that. All righty, have yourselves a great couple of days, and I will talk to you soon.